I have to thank the organizers, mainly Sebastian, for inviting me to talk about one of my favorite subjects. It's not that we only do this, we do all kinds of spoilage, even bacteria, Alicyclobacillus. We do a lot of pathogens, like every lab, but this is one of our specialties. So we are well known for our work in food mycology. So this is my agenda. I'm going to talk about the spoilage problems. What are the problems caused by bacteria, and what are the ones by fungi? Now, then I will go to Alicyclobacillus and the heat-resistant molds, because I thought that for this audience, those were some of the more adequate. There is a lot of other problems, but we'll have to do that in another presentation. Then a little bit on prevention, my recommendations and conclusions. So certainly, because these products are thermal processed, you are going to have problems with heat-resistant microorganisms. And these are the heat-resistant molds and the heat-resistant bacteria. But they also have a problem with heat-sensitive microorganisms. The heat-resistant microorganisms are soil microorganisms that they contaminate the ingredients and packaging and other things, and they survive the thermal process. They also survive and get activated by the hot filling. With the heat sensitive, it's always a problem of faulty caps, of non-aseptic conditions if it is aseptically filled, and certainly they are a problem with biofilm. I don't think the beverage and juice industry does a good job getting rid of biofilm, as we have seen. So the first thing I'm going to talk is about the spoilage caused by bacteria. And certainly you have the heat-resistant Alicyclobacillus and Sporolactobacillus. This is a lactic acid bacteria that produces spores. And the heat-sensitive lactic acid bacteria, acetic acid bacteria, and I cannot go over them, but they are certainly very important. So I love the Alicyclobacillus best practices guidelines of the European Fruit Juice Association. It is very informative, and you will see a little bit of that in this presentation. So for Alicyclobacillus, it was detected first in the soil of orange groves in Brazil, not only the soil, the fruit, the leaves, the irrigation water. So it is a soil contamination problem, which is the same for HRMs. You'll see how similar both of these groups are. Then the first time that we recognized there was a problem was in 1982, when in Germany they produced apple juice and they let it cool down naturally. There was a big problem, a big spoilage, and the spoilage is flat sour. What does it mean? They do not produce gas. They do not change appearance. It's very difficult to know that the product from the outside is spoiled. But when you open it, you can certainly notice these off flavors and off odors. So it's what we call a flat sour spoilage. Certainly one of the characteristics is that it can be in water. While with heat-resistant molds, we do not focus on the water as much as in this case. The condensate water can be a problem for fruit juice manufacturers. but it has been found in many other places. So it is estimated that 30% of the fruit already has it, and 15 to 75 of the fruit concentrates may have ACVs. And I'm going to talk about ACVs, but some people call them TAB, thermophilic acidophilic bacteria. And but not necessarily all of the ones that we find are going to cause spoilage. They think about 20% of them will cause spoilage in the right conditions. So they need a high water activity, so juices are perfect, beverages are perfect. They can grow up to bricks of 18 or a little bit over 18. And this is something that you have to have in consideration when you are doing testing. And so there are spores in concentrates and in liquid sugars, but they are viable. They will not germinate even if they are activated because of the bricks. It can grow at a pH range between 2 and 6, and certainly 3.5 to 4.5 is ideal. So for many of the juices and beverages, they are ideal. And temperature from 20 to 60, but 40 to 50 is more ideal. Stricter rules, but of course there is always an exception. So we have found some strains that can grow under anaerobic conditions. Now, what fruit juices are more susceptible? Certainly many of them, starting with orange, pear, and then you have the apple, peach, many of the fruit juices. Now, the growth rate will be variable depending on the fruit juice. Passion fruit will be stimulatory, but then it doesn't grow very well on apricot or red grape juice. But we have found that in many beverages, including teas, shelf-stable teas, and carbonated fruit drinks, and canned and diced tomatoes. It cannot grow with an alcohol content of more than 6%, so the wines seem to be okay, but ciders and shandies and things like that with less alcohol can be susceptible. And certainly the spoilage occurs at a higher temperature. So even though some of them can grow at 20, they do not like growing at 20 if they grow slowly. But when the temperature is a little bit higher, so think about summer months. It is very difficult to keep storage under 20. So I agree that the risk of Lactobacillus is dependent on the type of product and the type of process. You cannot make it general, you have to know what the conditions are. Now, the main compound that will produce this type of spoilage is guaiacol, but certainly there are others like the halophenols. For guaiacol, we have several precursors, and the halophenols are the dibromo and dichloro. So guaiacol is what we're looking for, even though remember, other ones can be there. And you need a concentration of more 10 to the 4th or more to make enough guaiacol, so it will give the spoilage. Now, all these are precursors. So if we've seen beverages like sport drinks, and if the flavoring didn't have some of these, vanillin or vanillic acid or something like that, they did not get a spoilage. So one of the things, consider removal of the precursors or dissolved oxygen or headspace oxygen. Very difficult to do. So there are many species now. I think the last time I looked was 22 and going. So Alicyclobacillus acidoterrestris is certainly the most common. I mean, we have isolated the most common. However, we recently got from an sport drink Alicyclobacillus acidocaldarius. And in this case, it does not produce guaiacol, but it does produce other compounds. So do not discard it. Then you have contaminants, Herbarius, Pomorum. They all produce guaiacol, Psychoheptanicus. Hesperidium is mainly a soil organism, but give it time. And then Fastidiosus saccharide in liquid sugar at the moment has not been reported to produce guaiacol. Then Acidophilus and Dausi. These are just a few of them, but believe it or not, they are coming with more. And yeah, they are not as important as acidoterrestris, but you still have to go for the total guaiacol producing species. So what are the sources? Certainly, we don't know about packaging, but the main sources are the ingredients. It can be fruit juice concentrates and purees, certainly the liquid and granulated sweeteners, tea and herbal tea, leaves, flavorings with Alicyclobacillus, processed water is very important if you are a fruit juice manufacturer. The equipment, Alicyclobacillus produces a lot of biofilm. So you have to realize that you will end up with biofilm in your equipment. Packaging, we don't know. It's not like with heat-resistant molds that we have studied packaging a lot. With this, we really do not know. So for the other main spoilage by a heat-resistant microorganism is, well, the molds. For the fungal, you can do both. You have the heat-resistant molds and then the heat-sensitive and the yeast. Like I said, it is a problem with biofilm, air, and an air rinser if you have an air rinser, things like that. Now, you can read more about all this in one of my publications in 2019, Fungal Problems in Thermal Processed Beverages, and if you want a copy, just let me know. Now I'm going to talk about the heat-resistant molds. So, because there are two types of beverages, the ones that are hot-filled and the ones that are cold-filled or aseptically filled. Both of them are going to have a problem with heat-resistant molds because they are thermal processed. Doesn't matter that one group are cold-filled. Now, the group that are hot-filled have the problem that if the ascospores of HRM are inside of the bottle, they will be activated. And again, if you want to read more about this, you can go to my publication in 2017. And if you don't have it, just contact me. So with HRM, certainly they are found in cultivated soil. This is the same problem as Alicyclobacillus. In this case, it's a visual contamination. You are going to see the mycelium growing in the bottle. Some of them produce pectolytic enzymes. So if the juice has a cloud, then you will see that it starts breaking, it starts clearing, because they are breaking the pectin. And certainly some of them produce gas. And we have isolated them from ingredients, the processing environment, packaging, and all kinds of areas. So a little bit background, they can survive not only the thermal processing, but also the high pressure processing. And in fact, what these are doing is activating the spores so they can grow later. So you are actually making them a favor so they can grow. Then they also produce some mycotoxins like Bacillomyces niveus with patulin. And they grow under very, very little oxygen. People think molds need oxygen. No, not all the molds need oxygen. They grow with only the dissolved oxygen. They can grow in biofilm. Mold are present in biofilm. Um, and they also can grow at a breaks of 30 to 35. So then again, when you are analyzing for them, you have to have this in account. Certainly the cold chain distribution, the same as with Alicyclobacillus, will slow this type of spoilage. Now, starting in 2011, they started to consider these molds always had two names. The one name of the state that had the sexual state with the ascospores, and the name of the asexual state. Well, it was quite confusing. Coming molecular tools, they said it's the same mold, why are we calling it two names? So then they went to what they call one fungus, one name. So it was a fight between medical mycologists and food mycologists. For us, we like the name of the sexual state because they have the ascospores. They mean something to us. They are heat resistant. Medical, they wanted their names. So most of the medical won. So we have lost Bisoclamis, Neosartoria, Uroshium, Emericella. The only one that is being conserved is Thalaromyces. So you have to have that into consideration. You can still use the other ones. Nobody's going to put you in jail or anything. But you have to know that when you are looking for things in the literature now, it will be these names. So this is what I'm talking about. You have a sexual state that produces conidia, not heat resistant. And then you have the sexual state that produces ascospores. And the ascospores come in an ascus of 8. And when the ascus is mature, they are released. That is the heat-resistant state. These are some of the ascospores. To me, they are beautiful, but to some people, they hate them, of course. But, oh well. And then the decimal reduction values of these molds are pretty high. I mean, you know, they can survive 85, 90, 95 degrees, which is the processing that we give a lot of the juices and other beverages. Certainly, they are not as heat resistant as Alicyclobacillus, but you know, they are quite resistant. What happens with the Ascospore activation is that they are in a dormant state. They have a very thick layer, and they need a trigger, and that is heat, is high pressure or high chemical concentration, and that releases, opens the layer, and then they can germinate and grow. And this is what's happening during storage. And of course, we also recommend the method for many things, many samples of heat-resistant mold testing in the compendium of methods for the microbiological examination of foods, and certainly the IFU is working on a new one, so that will be also a good one to have. The sources, again, packaging, the processing environment, dry ingredients, and liquid ingredients. And in the liquid are the same, just about, as the ones that we saw before. You can add coconut water. You know, it can be a high source of HRMs. We did a study on the sweeteners in 2006, 2007. We did like 1,000 samples, and we found them in all the sweeteners. It didn't matter if they were from beet, from cane, or even high fructose corn syrup. They were in small concentrations, but sometimes even one ascospore per 100 grams will give you spoilage. Then, of course, the dry ingredients, pectin gums, additives, you know, things like that, the energy supplements, vitamin supplements, and that is because of many times the maltodextrin, very risky. We did the environment, and I'll show you a little bit on that. It is all over the environment. They are everywhere, just about. And the packaging, and we did the same, about 1,000 samples of bottles, and we found that the people that bring the bottles in the plant had a higher concentration of these ascospores than the people that were blowing the bottles next door or at the plant. So we did a study on the environmental HRM in the fruit and beverage processing plants, which is the first two. And certainly we found them mainly in areas that have to do with packaging. So the decal, the slip sheets, the wooden pallets are horrible. The wrap around the pallets, anything that has to do with packaging, but they were all around the area. In the second set of graphs, it's in the bottle facilities. We did 15 or 16 of the manufacturers of juice and beverages, and the one in the bottom, we have about 9 plants of the bottle manufacturing, and they also have them there. We have some with the cap manufacturing, they also have them there, but the variety is a lot higher in the beverage and juice manufacturers because they bring in everything, all kinds of ingredients, all kinds of packaging. So certainly they have less variety in the bottle manufacturing and less in the cap manufacturing, but they all have them. We studied sanitizers against the ascospores because they are very, very, very tough. But we found that chlorine dioxide in solution, 200 to 500, kill them, which is very unusual for things like this. We did publish that study too. And I know in Europe, I don't think you use chlorine dioxide for this purpose, but in the US, at least we can use this to get rid of them. So the processing parameters, so you are gonna put some parameters to try to inactivate these spores or ascospores, and we know that pasteurization, it will not work. If you have enough and mature enough spores or ascospores, you will have a spoilage. High pressure processing, it will not be effective only by itself. And then you have combinations of high pressure and lower temperature, which it will depend on the conditions of the product. It certainly may work better. Okay, so after that, okay, you couldn't inactivate them. Now you're hoping that your formulation is going to get rid of them, or it's not going to allow them to grow. So you have preservatives. Well, that works for ACVs, but it doesn't work for some of the HRM that are preservative resistant molds also. You have essential oils. Some of them are effective, but certainly it changes the smell and all what the beverage is made of is completely changed. So we need more information. You have plant extracts and juices, grape, seed extract, pomegranate, cranberry. They are effective for ACVs, but still we need more information. Then niacin certainly is effective for ACVs, but not for HRMs. And the problem is that they inhibit the gut microbiome, so some people are having problems, adding them. So you're gonna need multiple hurdles to prevent both. You can do high temperature processing and preservatives, not for all of the HRMs. high pressure, the same, not for all the HRMs, processing and nicing for ACVs, and some others. But you really have to use different hurdles. And remember that at that point, it may be too late. You have to start from the beginning. You have to start from your raw materials. That is when you start preventing. Because once it is in your product, game over. So I want to give some recommendations. Certainly establish microbial specs that have both ACVs and HRMs. You don't know how many people do not have them in their specs. And do not allow your vendors give you the specs. You are the one that have to determine what your specs are going to be. For HRMs, we certainly recommend that they are done per 50 to 100 mils or grams. The higher, the better. We've seen a spoilage with one Ascospore in 100 grams. We've seen a huge spoilage with 5 to 25 Ascospores per 100 grams. It's between 3 and 6% spoilage. So that is very important. Monitor the raw ingredients, maybe packaging is not done as much, and equipment and environment. And certainly use the right methodology. Is it very slow? Yes. We need faster methodology. I know that for ACVs, bioMérieux has the GNAP Pro ACV that we have used in our lab, and it can do total species and the Guayacol producing species. So that one worked very well. Now for heat-resistant molds, yeah, we have to try, but it's going to be challenging because the concentration is so low. Then you have to establish a testing regime for the water. This is important for ACV. And carry out supplier and raw material risk assessments. See what your supplier, how they are handling your material. Certainly, if you can, which in summer, cool the product at less than 20 degrees centigrade as fast as possible. This works with ACV, but with HRMs, the harder it is, the slower they grow. So if it's hot during storage, ACV grow crazy, but HRMs will not. They take a lot longer. Then establish a strong sanitation program, and this should be a sanitation program that eliminates also biofilm. Certainly dry cleaning areas. How do you do it? How do you clean a palletizer? I mean, no. you can do something, you know, but when you see all the overheads and everything that are difficult to reach, I mean, it's just a lost cause. Then you have the rinser that you hope will eliminate them. Prevent biofilm formation, very, very important for all of them, ACVs, and the heat-sensitive yeast and molds. Which, by the way, this biofilm is already coming to you from the drinking water municipal systems. So a lot of these spoilage microorganisms that we see in beverage and juices nowadays are already coming with the processing water if it is not treated, or for cleaning. Many people use that water for cleaning, and they are introducing all those in their processing. And then use the right sanitizer. Not all of them work. And the right concentration. And a lot of people don't know that there are two concentrations. One is the food contact. The other is the non-food contact, a lot higher. And that's the one that you have to use to eliminate the spores and the ascospores from the processing environment. So both ACV and HRM are found from similar sources and behave in the same way. Many times you have to think, well, if I have ACVs, it's because I have soil contamination. Maybe I have some HRMs. The spoilage can be reduced, and see that I say reduced, because I don't believe the spoilage can be completely eliminated with the way we do things nowadays. And you have to apply several prevention measures or hurdles. And it is really unrealistic to guarantee that any product will be 100% free from spoilage. I mean, I know the beverage industry will like to have less than one consumer complaint in 1 million bottles. I know, that's my, that's my, my same reaction. I mean, hello, there is no way. You're gonna have a baseline spoilage, because as I say, it's very difficult to eliminate all the HRM ascospores from all the processing. So 1 in 1 million, 1 in 100,000, it's gonna happen. So yeah, what you want to eliminate or to prevent is the big spoilage case. You don't want that. And you can do that by what we've talked about, monitoring ingredients, mainly. And then the packaging and the environment, the processing environment is gonna give you a much lower spoilage. It will, but it will be lower. But yeah, I do not believe on 100% spoilage free. So, but it's a continuous problem, and you have to be on top of it. So I think that's it.